Hello everyone. So in this video I will demonstrate the DreamScene 3D artist AI agent. So this is the Capstone project for the Google Intensive 5 days AI training. So basically I will go through uh, the architecture and some overview, and then we'll go straight to the interactive examples. So basically DreamScene is an agent that is using existing 3D assets that it has, and it interacts with the users and using some available tools and the prompt descriptions that it has, including the overall functionality, the examples, the way to calculate certain aspects for the 3D, and also image understanding if the agent or the LLM model wants to see or look at some of the scenes. And then, based on the input and the discussions with the agent, it can create from the available 3D assets, it can create a new 3D scene and save it to persistent memory. So that's the overall architecture. So we have the agent application, it has the LLM model, it has multiple prompts to describe what exactly it needs to do and how. We have a number of available tools, and we have persistent data. So that would be the assets and the outputs that we are producing. So in here we have the description, the details, and some of the topics I have covered. And in here, those are actually virtual camera rendering in 360 view of some of the created assets from the dream scene. And you can see that's a composite scene here. And just to note, all the 3D assets are 3D Gaussian splitting assets, and they have been trained using Nerve Studio on open source datasets. So I will not go through the code one by one. Maybe I'll create a different video to add a code, to add a description for the code. But let's go to the interactive chat. So for the sake of committing to the Kaggle, I have one example with the step-by-step messaging to the agent, and I have commented out the interactive chat. So we will comment this one back. We will run it and we will see what we can do. Okay, so here that's basically the opening message of Dream Scene. It basically explains what it can do, and let's maybe ask it. Okay, what scenes do you have available? So now using its tools, it accesses. So if you have a look here on the data sets, this is the persistent data. This is our data set that actually has the actual 3D assets and the description for those assets. So using those tools, we access this data set, and this is how we got the um, how we got the reply. So let's try. Okay, what objects do you have? Okay. Let's maybe have a look on the forest. Can you show me how the forest look like? Okay. Might take a minute now. It could be a bit slow, but now it has visualized again a virtual camera rotating 360 about the forest. So that's maybe okay. Um, I want to create a scene similar to the movie Cloudy with a Chance of Meatballs, with a lot of floating food falling from the sky. Can you create this scene. Okay, let's see. Okay, so we got a detailed reply here. Okay, so it seems like a fun scene to create. Okay, so side the street is the base. Okay, I was hoping for the forest though, but let's see what will be the output of that. So since the movie features various food, I'll focus on replicating plate object. Okay, so the scene is the side street. The object is the plate repeated multiple times, and this is basically based on the logic in the prompt that explains to the agent um, how to specify a location of the input object. So here it's basically explaining how it will scale the object, and those are the plates here. So he's creating 5 plates and he's explaining where he will locate them and how he came to those calculations and so on. One thing I noticed here is that okay, he's varying. Okay, he's very. I was going to say that the z is constant, where we have explicitly said that we want those to be floating. So he's varying those here, basically randomly. Okay. Um. Okay. So let's have a look at this. Can you create this scene? The output file name is street meet walls. Okay, so this will take a while because the function um, that is creating the scene is actually quite slow due to the way it writes down the output file. So I might speed up the video to see the output of this. Okay, so this wasn't too bad actually. So it created the scene. We can ask it to give us a look. Can you show me the created scene? Okay, so we have the created scene here. I only see. Actually, it's very hard to see any plates. So let's. Oh, there is one plate in here. So let maybe ask him to have a look and see what's the problem. One of the tools is using image understanding, and the agent should be able to look against the X and Y axis and have a look over the scene. And I only see small plate. Can you have a look and see what's wrong with the scene? Okay, so this is basically a display of what the model is seeing. So it's looking along the x-axis and it's looking along the z-axis. And now it's still processing, so probably it's trying to recalculate what should be the modified positions in that case. Okay, so that's the new scene, and this is actually much better here. So you can see that we have a multiple of plates floating around in the area. And this is just the visualization of virtual camera rotating around. But we can here download, so the output, so the name of the file that we requested, I think it was street meatballs. So if we look here, we should find this file created. Yeah, this is the file. So we can download this poly file. Again, this is a 3D Gaussian splitting scene. So when we download this file, there are a number of open source online viewers for this 3D Gaussian splitting. So one that I think is quite nice, and it also acts as an editor, is this super split. So once we downloaded the file, maybe we'll have a look over it in there to be able to see it maybe a bit freely than this visualization here. Okay, so we have the file downloaded here, and I'll open it here. So again, this is the file created by DreamScene. Okay, so it will take a minute. It's quite a big scene. So I'll try to orient it here. Okay, and the blue points are actually the midpoints of the Gaussian. So I'll remove this so that we are able to see it. Oh, actually, this is quite good, actually. So I'll try to maybe rotate here. Oh, this is quite good. So I will add a rotation here. Okay. So oh, look at that. Oh, this is actually nice. So this is basically like kind of a start agent if you want to use or create scenes for your, I don't know, games or just 3D navigation. So it is actually quite nice the way it has created it. Okay. Oh, this is not too bad. And this is pretty cool. So let's try something different. Okay. Um for me, a forest scene with a few plants on the ground and a tractor on the side. Okay, let's see. Okay, so again, here it's explaining. So it will use the ficus, that will be the plant, and it has a tractor, it will use the forest, and again, it's explaining how it came to the conclusion of the required scaling. This is again based on the prompts. It has the translation. It won't apply rotation. That's fine. Okay, so yeah. Okay, please create the scene. The output file name should be um, forest with tractor. Okay, so now the scene is ready. Okay, so it has created it and saved it to the output file. So if we refresh this one, we should be able to see the file created. Yeah, here for us to structure, but let's ask DreamScene to visualize it. And you show me the output scene. Oh, okay, here it is. Okay, so here we have the tractor on the side, and this is the forest. We have a few plants placed around. Okay, again, our virtual camera is going through the tractor, but let's have a look on the actual output file. So we'll download this file. So it was forest with tractor. Okay, so I'll download this one. Okay, so I will. Okay. So this is an open scene, so we should have a better visualization here because we would have a surrounding walls similar to the street scene that we were seeing. Okay, so again, I will disable the midpoints here so that we can see. Okay, so this is actually, it's not bad. It's good actually. So you can see those, they're all the same size, but again, we didn't specify for Dream Scene to resize them. So he has a couple of those, and then he has the tractor. He tried to scale the tractor to a realistic um scale, and that would be based on the information that is provided in his data set. It's not too bad, it's probably a bit big, but it's not too bad. But I think overall the work that I have done was it was actually quite interesting, and it wasn't a smooth ride. So like if you look at the prompts here, you can see that I have a number of prompts that I did not pass in, like this silent, for example. I was hoping that I can ask the LLM model to do his own calculations silently without explaining to the user how he's calculating certain positions and so. But I found that when I enabled this one, there was errors with the final results. I haven't investigated a lot whether that was consistent all the time or not, but I have just disabled it. But in general, there was quite few trials with different methods. Like sometimes, if there is too many rules, it somehow constrain its ability to be creative and suggest like cool scenes and so on. So maybe I'll create a different video to explain the steps that I have followed and the different wrong paths that I went through, because it's interesting to know what is working and what is not working. But overall, I think it's a quite promising agent. I also have a list of future improvements. I think there is a lot of improvements that are possible for this agent. Actually, it's just basic functionalities here, but we could basically expand it to add new 3D scenes. And I think if it was redesigned with multi-agent, the overall performance might be better, because you can see it's a too much functionality and information for one agent, or sorry, for one LLM model to kind of handle and digest. So it's basically doing everything. It's handling the user interface, it's handling image understanding and looking at different images, it's handling calculating certain positions and so on. um, I think it might the performance overall and the results might improve if we have multi-agent architecture. Um, but that's again for the future work. So anyway, this was an overview of what this agent can do, and I do encourage you to enable those cells and try it yourself and see what it can do, or maybe ask it to suggest something, a certain scene. It is important to know that this is running on a GPU for, because it's required for rendering the Gaussian splatting to have those views. So on the accelerators, it should be configured to a GPU environment to run on that. And that's all from my side. I hope you like it. Have a good day.